Now that the EmissFire machine has indicated that cylinder 1 is the misfire, it's changed our whole diagnostic strategy. It's not 4 that's misfiring, it's 1 that's misfiring. The scan tool has misled the technician to making the wrong conclusions on the cylinder. Now that we know 1 is the misfire, let's take the spark plug out and check the compression on cylinder 1. Now we have the plug out, let's put the compression hose in. We're going to take this compression hose and we're going to put it in the spark plug hole. And then we're going to take this 300-pound pressure transducer and attach it. This 300-pound pressure transducer is going to send a signal to the EmissFire, and we're going to be able to figure out if this cylinder is good or not mechanically. Now that we've got the compression tester in cylinder 1, we have to do something with the open wire so it won't create a spark or damage the module or the transducer. We're going to take a spark plug load tester, put it in the wire, and ground it. Now we're going to take the inductive clamp off of number 2, and we're going to put it around number 1. Now we're going to connect a -30 pressure transducer to the intake manifold. This will give us the intake manifold vacuum readings so we can compare those to the in-cylinder readings, and also so we can make sure which valve is bad. We'll use the PCV hose. We'll connect it. Now we're going to connect the -30 Hg pressure transducer, which is a vacuum pressure transducer, to the intake manifold vacuum. We want to use a centralized vacuum port, such as this PCV hose. We're going to connect this into the PCV hose so we can get a vacuum reading from the intake. We're going to disconnect the pressure transducer that we had connected to the tailpipe exhaust from earlier. And we're going to now plug in the 300 pressure transducer that goes to cylinder 1 in channel 1, and we're going to connect the -30 or vacuum transducer in channel 3. We're going to change the configuration now so we can read the pressure transducer we put in cylinder 1 and the vacuum that we put in the intake manifold correctly. We're going to move to the configuration tab. We're going to select compression, and now the system is set up to read the compression. We can either go to the compression window to get data or the measure. We're going to disconnect the coil now. Now we're going to do a cranking compression test. The coil has been disabled, so we can just get a crank. We'll now pause the data. We'll get the zoom window. We'll come in and we'll zoom in on the pressure so we can look at it more closely. Immediately we can see that we're only making 7 pounds of pressure. This is very, very low. So we know that we have a problem. Let's look at the waveform so we can figure out where our problem is. We're going to smooth the waveform with a process and a smooth data, which is a boxcar style filter. Right away, we're going to put our cursors up on here. And I can see the tower is leaning. If I put the cursor right through the center, one side is closer than the other side halfway up the ramp. This is an indication that this is a mechanical failure anytime I have a leaning ramp that's over 20%. The other problem that I have is I can see clearly that my intake vacuum pulls dropped when the intake valve opened. The intake valve opened right here. As soon as that intake valve opened, the intake lost pressure until the intake valve closed. The intake valve closing is occurring here. So the intake opened and the intake closed. As soon as I closed, I was able to build vacuum and it built up again. During the point that the intake valve was open, I lost intake pressure. This shows clearly that my problem is an exhaust valve is causing this. So I have an exhaust valve that's not sealing correctly. Now let's start and run this vehicle. The engine is now running. This is a live waveform that's an indication of the pressure. The pressure is building, coming down the exhaust pocket, the intake pocket. Right away I can see that the intake pocket and the exhaust pocket are different levels. The exhaust is lower than the intake, and it's very rounded. There's no definition. The machine is telling us that our intake vacuum is low. We're only making 11 inches of vacuum. The difference between the in-cylinder vacuum and the manifold vacuum is within 3% of each other. The compression is way under target. The target is 56, 57 pounds is what it should be making. We're only making 30 pounds of pressure. So we're 45 to 50% too low on the pressure. The machine is giving that to us. The intake cam is showing a retarded position. This is due to the exhaust valve losing the vacuum. Let's do a snap test on the throttle. Now the snap came up very good. The snap actual is 219 and the target was 205. This is because as the speed of the piston is increased, the pressure can't leak out as fast, so I still build pressure. So during a snap test, I only had a 7% differential. The problem with this engine is that the exhaust valve isn't seating. What we're going to do is we're going to pause this and we're going to go back and we're going to look at some of this data. We're going to again smooth this feature. If we look at the exhaust pocket, do you see how sharp this is? Do you see how off with the divot right here? If you look at the exhaust pockets, they're changing cycle to cycle. This is an indication that the exhaust valve is not seating. This whole process to find that this exhaust valve is bad on this Chevy Venture van is under 30 minutes. It targeted the misfire to the correct cylinder and then targeted the compression and gave you the analysis of what was incorrect with the motor, what was wrong. What was wrong is the exhaust valve. If the scan tool would give the technician the correct data from the beginning, that cylinder 1 was missing, not 4, he would have found this misfire quickly. The problem is he had already seen that cylinder 4 had a problem. The intake valve was stuck open, as we've seen. Now that the scan tool still identifies 4, it just gets him confused. To take the confusion out of your diagnostic work, you need more advanced equipment, such equipment that ATS has pioneered the research and development of these fantastic tools. What you need in your shop is an EmissFire. Stop wasting your time and your money. Make money the smart way, quickly. Go with ATS equipment.